Hello everyone, welcome to my channel C and Data Structures. And today's session it would be data types. So what is a data? Why we need data types? What are the different types of data types that are present in C language? Okay, so let's get started. What is a data? A data is something which holds some information, right? So let's take an example. We can have a student information data. So a student can have a student name, ID, age, address, gender, and percentage. Okay, so these collectively we call it as one student data, right? So at the same time we can have any type of data, like it can be employee information data or any other information data, right? So, so why we need data types, right? So if you take below example, like student name, ID, age, address, gender, and percentage, right? So if you look into this information carefully, so student name is a string, and whereas ID is a numbers, and age is again a numbers, and address is a collection of both alphanumeric that would be numerics as well as alphabetics. I can say string, right? Gender again it's a male or female, right? So percentage it would become come as decimal points, right? So so we cannot have one single data type to hold all the information, right? So that is where we have different data types in C language. So these are the different data types that are present in C language. Like there are four types. One is primitive type, derived type, and void and enumerator. Okay, so coming to integer primitive data types, we have integer, floating point, character. Okay, so we do have arrays, pointers, structures, and unions, which we're going to discuss in the upcoming sessions. However, now I'm restricted to explain about primitive data types. Okay, so when I talk about primitive data types, we have integer, floating point, and characters, right? So let's get started with integer. What are the different types of integer that are available, and what is the memory that would be occupied for it, and how do we can access that, right? So these are the integer data types that are present in C language. Okay, so short int. Okay, so if you take short int, it is by default it would be assigned as signed short int. Okay, and for that the memory occupied would be 2 bytes. So we all know that 1 byte equals to 8 bits. So if you look into the range of short integer, right, it would be minus 2 to the power of 15 to 2 to the power of 15 minus 1, that is minus 32,768 to minus 32,767. Okay, so what is the difference between short int and unsigned short int? So both occupies 2 bytes, but if you could look into this range, right, so it would be there are no negative values in unsigned short integer, whereas in short int we have negative values too. Okay, so if you look into the format specifiers, it has both percentage hd, percentage hd. So we're going to talk about this format specifier, why it is used in the while writing the programs. Okay, so let me come back to this short int and unsigned short int. If you look into it, like it is negative values, it doesn't have negative values. Okay, so how do we know that computer knows that it would be only negative values, as well as it will be only positive values only, right? So uh, so why it is only 2 to the power of? Why not 3 or 4, or it can be 10 as well, right? Why only 2 to the power of? The reason behind that is computer understands only binary language, like it is zeros and 1. So we got only two numbers. That's where it comes with only 2 to the power of any number. So 15 is like 1 byte is equals to 8 bits. In that case 2 byte equals to 16 bits. So 2 to the power of 15. So I mean 16 minus 1. So why that 1 bit is left over is to represent the sign of the number. So sign here is we have in most significant bit, which would represent whether a given number is positive or negative. So that most significant bit won't be present in unsigned short integer. That's where you could see 2 to the power of 16 over here. Okay, so this is short about short, and when it comes to integer, int is, we call it as an integer. So here it is only 2 bytes, and the same range that what we could see in short int, same would be this for integer as well. Okay, so it all depends on how much memory it would occupy for the data type. If it is 2 bytes, it would be minus 2 to the power of 16 minus 1. you know I can write a formula like, minus 2 to the power of n minus 1. So n as number of bits. Okay, so 1 byte is equals to 8 bits. Whereas when it comes to unsigned int, same for whatever we see it in short int, same would be applicable for unsigned int as well. So if you want the range greater than this, like 32,767 or 65,535, if you want greater than, if you want to accept numbers greater than that, this range, then we need to go for long. Long is a data type which occupies 4 bytes of memory, and the range is like this, and same is for unsigned long as well. So this memory, whatever memory that you could see here, right, this could varies from compiler to compiler. So in order to know how much memory that each data type would be allocated, we can, by making use of size of operator, you can see that. So I'm going to demonstrate that with the help of a program. We can see that at the end of the session. So the next data type is float and character data type. So wherever, if you want a decimal points, then we go for float data type. If it is if the range of that is 6 decimal points, we go for float data type. If not, we go for double data type, which can accept up to 10 decimals. And if you want to go for more than that, then we go for long double, which can accept up to 12 decimals. So this has a memory like, float accepts 4 bytes of memory, and double 8 bytes of memory. Long double, it would be 10 bytes of memory. So character data type, char, represents the character data type. So character data type, if you look into it, it accepts only 1 byte. 1 byte is equals to 8 bits. So that is where we got 2 to the power of n is 8 bits. 8 minus 1 is 7. So that's where we got minus 2 to the power of 7 to 2 to the power of 7 minus 1. Minus 128 to 127. Unsigned character, if you look at it, it again accepts only 1 byte, and that is 0 to 2 to the power of 8 minus 1, that is 0 to 255. The format the format specifier is %c for character, and %l, capital LF, is for long double. For double, it is small letter LF, and float %f. So we all know that C is a case sensitive language. So small l is different from capital L. Okay. Okay, so that's it for data type, primitive data types that are available. Let's get into the program which I have already written, and I can show you the how much memory that each data type would accept in C language. So it varies from compiler to compiler. For long double, you could see 10 over here, and for some compilers it would be 12 as well. Okay, so this is the program which I have written, and in my previous session that I have talked about what is clear screen, what is the purpose of it, get ch, and printf. So I have used only one extra operator, that is size of operator and %c. %d is represents integer format specifier. If you want to print any integer value, we need to use %d. Okay, so I have used all data types that we have seen here, like short integer, long, character, float, double, and long double. Okay, so I'm compiling this piece of code and I got success, and I'm running this piece of code which would show us how much memory that each data type would be allocated with respect to this compiler. Here you see size of short integer is 2, size of integer is 2, long it is 4, and character it is 1 byte, and float 4 bytes, double 8 bytes, long double 10 bytes. So these all in terms of bytes, not in terms of bits. Okay, so that's it for now. Thank you for watching. Happy learning.